So I'd like to welcome you to our OTF Connect session, Beyond You Can Do It, Supporting Productive Struggle in Mathematics with Kit Luce. Kit is an amazing presenter, and I know we're going to have an awesome evening learning along with her. So I'm going to turn it over to Kit.
All right. So welcome, everyone. You can see here that we're talking tonight about productive struggle. How do we get kids to stick with problems, to try challenging problems, to not get frustrated and give up, beyond saying to them, yes, you can do it, keep trying. So what are some strategies that research says are effective strategies? You'll see here on the front page the bit.ly. So you're welcome to keep a picture of that or write it down so that you can add this slide deck to your own Google Drive if that's something you use. But as always, the recording of this will be on the OTF website, so you can access everything there along with the links. And Mally has put the bit.ly in, so it's there for you too. So I always like to introduce myself a little bit just because you're hearing my voice. I live in Barrie and I work for the Simcoe County District School Board. Essentially I'm a math coach. I have a fancy title, but I'm a math coach. And what that means in our board is that I support 2 schools who are designated as our intensive support schools, and I work specifically with junior teachers. And we have coaching cycles where we meet with release time, we co-plan a lesson, then we co-teach that lesson, and then we debrief the lesson, look at student learning, and we're also looking at teacher practice, and each teacher sets goals for themselves to how to deepen their understanding of math pedagogy. So that's me. I have a wonderful family. One of my sons getting married this summer. We're pretty excited about that. We have far too many dogs in the house. And my Twitter is @KitLuce, and I'm fairly active on Twitter, and it's where I've done a lot of my learning over the last 2 years, I would say. So I would encourage you, if you are on Twitter, to check out some of the links and people that I follow and deepen your learning that way. So this comic really spoke to me because it seems that in our community, with our students, with our parents, with people, you know, in the general public, it seems like there's this perception that if you are good at math, it's because you don't have to work at it, right? So you have this math brain, or people who really like math don't have to work at it. And that's not true. Just like we have to learn to read and learn reading strategies to become a better reader, and how we have to practice writing to become better writers, we have to do math and work at math and challenge ourselves at math to become better. We're not just smart at math. So that, and I'm wondering, what would your students say about what does it mean to be smart in math? Do you hear comments from kids about who's good in math in the class or who's not good at math? And like Mally said, you can either type in the chat box, or if you want to click your mic on and just talk to the group. We're a pretty small group, so that should work too. So what do you think your students say? Who's a mathematician? Who's good at math? And one of the things I'm really good at is wait time. Right. So it's interesting, Carolyn, that even in grade 1, they're already associating being able to do operations, adding, subtracting, with being good at math. And then there's that fear of putting math in a context, in a word problem. That's great, Amy. That's who we want to cultivate. We want to build that throughout the grades. And Amy, what grade do you teach? In high school. Awesome. And Shannon, that whole idea that, you know, people are good at math naturally, that some of us are wired that way, and I truly don't believe that's true. I've thought a lot about this. I've done a lot of reading, really looked at what Joe Bowler is doing and what Carol Dweck is doing around that growth mindset. And I think that we can train our brains to think mathematically. And some ways might be easier for us than others. So I'm a really good example of that. I tend to think numerically about math, and thinking spatially about math wasn't as easy for me. But my growth in thinking spatially has been exponential over the last 3 years as I've dedicated time and learning to that. So that's what we want to change. And we want to help kids see that as we work at it, that math is about working at it. And that if you already know how to do the problems we're doing in math class, then we're wasting your time. And we want to give you problems that are worth solving. So let's go through some quotes. If you are not struggling, you are not learning. Do you agree? Disagree? Always, sometimes, never? Carolyn agrees. Josie agrees. Okay. What about Maria? Sometimes yes and sometimes no. Yep. Oh, and yes, the word discomfort is one I really like, actually, that sometimes we have that when we're trying something new and we're in a new situation, we have that sense of, I'm not sure about this. I'm kind of out of my comfort zone. All right, what about mathematics is a subject of learning and sense-making rather than a subject of performance? What does that mean to you? Maria, I agree. Most children, and I would say most adults, see it as performance. So can they add, subtract, multiply, and divide? Carolyn, did you have a question or want to make a comment, either in the chat box or your mic? Don't be sorry. I was all excited. Yes, and how do we help not only our kids see math as making sense and learning new things versus just being able to crank out an answer, and how do we help our parents understand that too? Okay. So you can see where I'm going here. What about this one? Engaging students in productive struggle is essential to developing deep conceptual understanding in mathematics. So if we believe this is true, that it is essential, then we have to make sure we're giving kids problems in which they can struggle, in which they can mess around, in which they can try new things and make mistakes and try a different way. And I really like that idea that learning sticks with us more when we struggle a little. Can you think of an example outside of math where you've seen people, they've had to struggle with something, but then they get it and they really own it? Learning to ride a bike. Yeah, that's both of you, right? Right. We want to, we don't want to give rules to kids where they don't have to think. And that's beautiful. It's not yours to wonder why. Just invert and multiply. When I used to think, oh, that's just telling me what to do with fractions and division. And then when I looked at it the other way, it was like teachers were telling me not to think. Just do it. Don't think. And that's what we need to move beyond. We need to get messy, try new things, maybe not get it today, maybe not get it tomorrow, but start to build that foundational understanding. All right, so tonight we're going to talk about why productive struggle is important in math and look at the difference between that productive struggle and that unproductive struggle. So we don't want to turn kids off. We don't want to make it so difficult that they don't see success, but we want to push them. And then we're going to look at ways as teachers that are the best ways to support that in your classroom. Tiffany, excellent. I wasn't able to attend that webinar because I was at OAME, but I'm really looking forward to listening to it online. And there's a great, I'm sure they shared in that resource, there's a great article called Nix the Tricks, as well as another one that's called 13 Rules That Expire. So those are things that you can check out. All right, let's get into some math. So we want to talk about tasks that encourage productive struggle. If we're going to get kids to challenge themselves, then we need to give them challenging tasks. So tasks that have that low threshold and high ceiling, where students can, all students can access the task, but it provides a challenge for them to move. They can attack tasks with multiple strategies, or there might be multiple solutions. Those are the ones that can get at pushing themselves towards more challenging math. So since we're doing math, we're going to try one. I add two numbers. I also subtract them. The sum is twice as much as the difference. What could the numbers be? So let's just focus on that part. I add two numbers. I also subtract them. The sum is twice as much as the difference. What could the numbers be? So grab some paper, something to write with. Let's figure this out.
Do you want me to put a couple minutes on the timer, Kit?
Yeah. So maybe put 2 minutes on the timer, see what you can come up with. And if you get a few numbers that could work, go ahead and try some numbers that don't work. Yes, Amy, I hear Marion Small's voice in my head lots of times. Okay, so as you're finishing up your work, start typing in the chat box, what two numbers could they be? Well, and we can add them right on to. So Shannon, I think that was you. You put in the chat box, but you also put it right on the screen here by using the text tool. So we'll wait for a few more entries. Three and 1, 3 and 9, 'Anyone else? Welcome, Lily. Do they have to be odd? That's a good question. Does someone find an example with even numbers where it works? Does the difference between the two numbers have to be even? Nope. So you think, Tiffany, you think yes, the difference has to be even? So we have 3 and 1. So 3 plus 1 is 4. 3 minus 1 is 2. The difference between 3 and 1 is 2. Let's look at it that way. So that one works. 3 plus 9 is 12. The difference between 3 and 9 is 6. 12 plus 4 is 16. The difference is between 12 and 4 is 8. So that's double. So what strategies were you using? Where did you start with this? Did you start with guess and check? Did you start with, okay, so you started with simple numbers, so starting with 1, and then guess and check? So I'm wondering if we gathered a whole bunch of these, what patterns we would notice, and how we could identify, do the numbers always, so do they have to be odd? Well, we've answered that because we had 12 and 4 works, and those are not odd. Does the difference have to be an even number? Okay, we said yes, we would have to see if there's exemptions to that, if there's examples where they wouldn't have to be odd. Okay? So you can see that this could be a task that encourages that productive struggle and perseverance. Oh, and Amy, right from that secondary perspective using algebra, you notice that you had to pick a number divisible by 3. So that's really interesting. So you can see as we work on this task with students from, grade 3 and 4 up to secondary, that all of those students could approach it, they could look for patterns, they could look for examples that didn't work. And how does that question differ from something like, what's 12 plus 7? What's 41 minus 16? Or even a word problem. I had 19 stickers and got some more, then I had 37. So how does this task, where it's open-ended, differ from a straightforward calculation. Also, Anik, you're noticing a connection between a number that has to be multiplied by 3 or divisible by 3. All right. Right, Carolyn, they don't have to worry about one correct answer. And the other piece of that is that there isn't just one answer. So those kids that whip through and say, I'm done, there's nothing left for them to do. But with a question, like I add 2 numbers, they can challenge themselves and look for those patterns. And you can ask them questions like, do they have to be odd? Does the difference have to be an even number? What about if the numbers weren't whole numbers? Does it work with fractions? So you can see how you can challenge. All right, we're talking productive struggle, so we're going to keep doing some math. What about this one? You can buy chicken fingers in boxes 6, 9, and 20. What exact numbers of chicken fingers can you buy? What are some exact numbers of chicken fingers you can't buy? Amy, I love how you're not, you're still going back to the same task. So the difference is 2/3 of the first number. So if you haven't quite satisfied yourself, keep that. Give it to your students. Put it up in the staff room. Share it at a staff meeting. We all had our staff meetings tonight, but you know, tweet it out. See what people say. All right, so we have chicken fingers in boxes of 6, 9, and 20. What exact numbers of chicken fingers can you buy? What are some exact numbers of chicken fingers you can't buy? So we won't spend a lot of time on this one, but this is also a task where the answers are endless. Right? And as you do more and more and more, the patterns start to emerge. So we can start to see multiples. And where do the prime numbers fit in all of this? And what numbers add together, and what combinations can you make? So again, a question like this encourages that productive struggle and that perseverance far more than 6 times 9, or I bought 20 boxes of 9 pens, or how much is 20 plus 9 plus 6. So far beyond those straight forward, one answer, one step computations, it encourages that play with numbers and particularly looking for the patterns. And I think that's so, so powerful. So we're going to watch a video now, and Mally, this is where the link will go in. The clip should, and I've checked it 4 times, the clip should start at 4 minutes and 50 seconds, because this is quite a long video, and we're not going to watch it all tonight. We're really only going to watch the 2 minutes. So if it doesn't start at 4:57, then just forward it to there, and we'll come back after a couple minutes. So Mally, if you could put that Dan Finkel link in.
Yeah.
To the chat
box.
Yeah,
I'm going to. So just click on the link. We're finding that if I put it in the web browser, it boots me out of the room, and we can't. I can't do that. So we'll put it in the chat box, and just click on the link, and it will take you directly to the video.
Perfect. So we'll put a timer on for 2 minutes, and then we'll gather back here. And as you're listening, I really just want you to think about whether you agree and what are some of the challenges with putting this into practice. Natalie, could you put a timer on for 2 minutes? Okay, if you could just put a check mark by your name so I know you're done watching before we continue. Okay, great. So what are your thoughts? Do you agree? What do you think the challenges was putting this into practice? Time. And Anik, tell me more about time. Right? So yeah, that discomfort, and Carolyn, that pressure of the curriculum of moving forward. Amy, the idea that students want to be told they're correct. They want to be right. They want an answer. They want to feel that they're getting it right. They don't want to sit in that limbo. And I think there's really important here about not being used to struggle, because it's so much more than in math, isn't it? We create opportunities for kids to fail and have to pick themselves up and try again? Or are we seeing in our students at a younger age that problems have been solved for them, right? That you know, not intentionally, but just as a result of our busy lives, do we do things for kids rather than let them do them for themselves, right? That low frustration tolerance and really just experience. And this is crucial for kids in particular too, who usually find our school world easy, right? And if we're not giving them these problems where they have to struggle, do they ever experience that that challenge, right? Do they ever experience failure and know that it's not the end of the world? Amy, and right, so they rely on the teacher to tell them they're learning rather than relying on their own sense of accomplishment. Right. I mean, I think about, you know, we used to look for Coles Notes versions of books, and in video games now we're looking for cheat codes so you can jump ahead, right? How do I figure this out? And how quickly do we give up? And adults are like that too. It has to be worth our while. So I encourage you to watch that whole video if you haven't seen it. Every time I watch it, and it's been a lot now, it's one of my favorite to use in PD I do. Watch it with that critical eye. See if everything he's saying applies to you. What don't you agree with? And see how it can apply to your classroom. So, my premise is that those tasks that lead to productive struggle are those that are within reach, but that present enough challenge. So they're not too hard, and that's the art of teaching there, trying to figure out what tasks are within their reach but provide a challenge. And we know that when we struggle and try something, that we really deepen our understanding of mathematics. And I forget who said it earlier, that those things that we learn through challenge are things that stick with us and we own. So how do we know if a struggle on a mathematics task is productive or unproductive? If we don't get off task. So if the goal of the task is what they're working on, then we know we're okay. If they get distracted by things they can't do. So for example, if the focus on a task would be looking for patterns, but they get distracted because the task is using decimal numbers or fractions or integers, then maybe we know the task is too challenging. It's taking us away from the intended goal. Right? If students can see that they're moving forward by their own actions, not by following step by step what a teacher is saying. And how do we typically respond when students are struggling? I think that's really important. Often our go-to is telling them. We suggest an approach. We correct an error. We say, oh, maybe you want to multiply here. Or, oh, check where your decimal is. Or we supply some piece of information. Oh, remember that there are 100 centimeters in a meter, or there are 365 days. So we tell them those steps. And our intention is good. We want to support them, but by suggesting that approach, we're using our ideas, and it isn't as effective. So a little bit more effective is that directed guidance. So, oh, let's break it down. What could you do first? Why don't you try this? So, you know, first, find out how far they moved in one step. I'm thinking about, you know, slope questions, or how a pattern on a graph changes. Well, remember, how much does it increase each time? Breaking the problem down in steps, it directs the student into how we approach a task rather than the student's way of reasoning. And a really good example of this is I was working with a teacher and some students on the idea of rates and ratios. And the task was about buying cookies. And the student was finding about whether the three cookies for a certain amount was a better deal than the 5 cookies for a certain amount. And I said, oh, well, what about, is there another way you could figure it out? And the student was building up. So they were finding 5 sets of 3 cookies and 3 sets of 5 cookies. And the teacher kind of shut it down and went, no, find out the price of 1 cookie for each, and that's how you do it. Find that unit rate. And when we do that, we limit the student thinking to the way we think about a task. And since, as educators, we are the product of our teaching history, sometimes we rely on those rules and procedures that we were taught, and we don't let kids explore. So the more effective is, instead of the directed guidance, the probing guidance. So ask the student what they're thinking. Ask them to explain what they've done in their work. Ask them how they could check. Ask them how confident they are in their answer. And those probing questions where you then walk away and say, think about that and I'll come back, is a much more effective way to push their thinking. And those most effective, the research is saying, are the open-ended prompts. So can you think of what that might sound like? What would an open-ended prompt sound like? If it helps, think back to the we add two numbers and subtract 2 numbers question, or the chicken McNugget question. Okay, Amy, yes, thank you. Can you tell me more about? I'm wondering. Right? So those open-ended, not even, you can see both of you had ... Right? So even that, I'm wondering, what are you doing there? I'm wondering, could you draw a picture that would show that? What made you choose this approach? How confident are you in your answer? Is there another way you could solve this? So those open-ended prompts lets the student own the strategy, lets them own their thinking. So how do we create a classroom culture in which that productive struggle is open, and that it's not only okay, but it's vital to learning mathematics, that we don't learn mathematics without struggling with problems. If we're not struggling, we're just doing math we already know. Right? So I really want to share this video with you. I love this little guy. It's about Rube Goldberg. So if you, Mally, if you could put that video in, it's about 4 minutes, and I think it'll be well worth our time to take a look at it. So when Mally puts the link in, if you can click on it, and then we'll put a timer on for 4 minutes, and we'll come back and talk then. So just as you're finishing up, if you could put a check mark in, that would be great. Perfect. So I love this video. I love this guy. This is what we want in our classrooms. And the question is, how do we do that? That not only is it struggle seen as essential to mathematics, but it's seen as part of the joy and excitement about learning math. That it's just normal. If we're doing math, we're going to be challenging ourselves. And so there are some really specific intentional actions that we can take as educators to help support this development of perseverance and that willingness to struggle with challenging math. So we're going to go through this, and I've built in some math to do. It's a small group, so I won't belabor the point, but I really encourage you to try the task tonight to add to our discussion, and then come back to them as we go. And they might all not fit your grade levels, but there's something in here for everyone. Right, Amy, and that idea that it's valued is not negative. So often we think, oh, it's, we're going to try hard and it's going to be tough, but you can do it. We need to move beyond the you can do it, right? That challenge and that struggle is a positive, right? So thank you for that. So one of the first things is asking questions, and we've talked a little bit about this. So what questions do you typically ask students when they're struggling? Are there some your go-to? Oh, what part is puzzling you, Tiffany? I like that. So one of my favorites is, oh, so you're saying you don't get it. What do you get? What part can you start with? Can you share your thinking so far? What steps have you taken? How do you know? Exactly. So there's a link here for this document that says 100 questions that promote mathematical discourse. And when you open the link, I want you to scroll down to the bottom of the page. Because what I like about this document is not only are there 100 questions, but they're categorized. So take a look at the last section on the last page. What would this look like in your class? Does one of those questions in that section about helping students persevere, is one of them new to you? One of the ways, one of the prompts and questions that I'm really encouraging students to use right now and teachers to use is there a way that you could draw a picture to show what you're thinking? Or is there a way you could draw a picture to represent the story in this problem? And so some of my learning right now is really focusing on encouraging teachers and students to think visually about problems and how to represent math visually. I went to a few wonderful sessions on this at the Math Conference, the Ontario Association for Math Conference last week, and it's that work I look for on Twitter too. So visualization of math. So asking questions to push student thinking. Another that's paired with asking questions is providing encouragement. Right? So not just saying you can do it, stick with it, but what can you say to your students to provide that encouragement? Okay. So go back to the document, and this time just scan through it quickly and choose one or two prompts that made you go, oh, I didn't think about that before. I'm going to try this new one over the next couple of weeks. So go back to the document, the same one, and pick one or two prompts and type them in the chat box that you're going to try. And Amy, I agree, the narrative is so important. Really thinking about the story and what's happening in a word problem. It demystifies them. Our kids are really good at reading text. We need to teach them the strategies for reading and understanding the story and context in a problem. All right, I'm going to wait a few minutes and ask everyone to type in one you're going to try that you haven't tried before. Dominique, thank you. How confident are you in your answer? I really like that, getting kids to reflect, right, to think about their thinking. Give me another related problem. Is this one easier? Right? So often we are teaching math in strands or in an isolated units, and they're not seeing the connection between say algebra and measurement. What if we're finding the area of a rectangle, can we not use algebra to do that versus number sets, right? Letting them see that connection. Maria, I also really like what did not work, right? And to me that sends the message that we're valuing those attempts that missed the mark. And I work with a teacher who, he starts off that consolidation all the time. All right, what didn't work? Let's talk about the challenges, and the kids get really excited about, oh, I have something that didn't work. I made a mistake, and it really creates that energy in the classroom. Tiffany, what have you accomplished? Right. And they may not get to the end of a problem, especially if we're working on, rich tasks that have multiple steps, multiple pieces they have to put together. So they may not get to the end, but what have you done? What steps have you accomplished? And Carolyn, to convince me that pushing kids to justify their answer is crucial. There is if you Google "convince me math," there's a whole bunch of resources out there that mathematicians and educators have created. Things like "convince me that 4 plus 7 equals 11," or "convince me that this fraction is greater than this fraction." And I'll look when you're doing some work in a minute, I'll see if I can find the link and place it. If not, I'll send it to Mally, and she can add it to the resources later. Shannon, I really like that. How could you help another student without giving them the answer? One of the other prompts that's similar to that I like is, how could you explain this to somebody who wasn't here today? So, all right, so we've asked questions, we're providing encouragement. And next we have to give them time. So, are we rushing them through? If we have to end the math class because it's time to consolidate, or the bell's ringing, or it's time for French, or any of those things, do we give them time? Do we let them come back to the same problems? Do we let them just sit and think about their work? And if they don't figure it out, then we don't have to give them the answer. We can come back and we can revise our thinking. We do that all the time with language and in reading and writing. But in math, it seems like we think, oh, we have to finish this problem in this 25 minutes that I've set aside for it. So giving that time, coming back, do we let them get up and walk around and look at the other people's work? Do we say, oh, maybe you two should change partners because you're each having different strategies and you could learn from each other? Okay. So I'm not going to do this now because I'm just looking at my time, and I don't want to spend the time doing this math, but a good idea for that, providing time and not stepping in, moving away from that, I'll do it and then we're going to do it together, is something like, how can you use what you know about the area of a rectangle to figure out the area of a parallelogram and a triangle? And just letting them explore. And I think back to our discussion at the beginning about not giving the procedures or the rules and nixing the tricks, right? So moving away from that procedure-based teaching to that exploration-based teaching. Really letting them just explore. And there's a link that Mally will put in the chat box for a GeoBoard app. And I find this is a great way for kids to explore area and perimeter. And I know some teachers are really hesitant to use GeoBoards, physical GeoBoards in their classrooms because of the elastics and all the complications that can happen with that. But this app is an electronic GeoBoard. And so letting kids explore those principles of area and perimeter can be really valuable. So I'll leave that with you. The next intentional act we can take as teachers is to acknowledge mistakes. And I guess my question is, how can we do this while maintaining that mathematical integrity? We don't want to say, yes, that, you know, well, you're not quite, or, well, maybe that could be. We want to acknowledge that there is a right answer and that accuracy is important, but we also want to value those missteps that kids take along the way. Anik, my favorite no routine, is a wonderful example of that. It's getting excited about kids' mistakes. A typical one I did just recently has to do with decimals and how we write decimals, how we say them, and how they're connected to money. So when I ask a student, how would you write $1.03, often students write, and I'm just going to type it down here. No, it's not going to show up right now. So the students will write thank you and a 1 and the decimal point and 3. And they don't see the connection between $1.03, 1.3, 1.30, and 1.03. So a teacher and I were looking at student work actually just today about that. So we acknowledge what is correct about it, how they're on their way, but we also want to maintain that mathematical integrity. So a good example of it is this question. So we were doing some work in a grade 6 class, and the question was, how much of this hexagon is green? And we had some students say 4/6, which was the answer we were looking for based on the work we had done. But a few students said, no, it's 4/5. And I'm wondering how you would respond to that. How could you honor their misstep when they said 4/5 while maintaining the integrity of the area model of fractions? Do you have any thoughts on that? I'm rushing my wait time a little bit. Normally I'd sit here and let us think. Okay, thank you, Tiffany. So I see the 4 pieces here you're talking about. Can you explain the 5? And explain to me what the 4 and the 5 represent in the image. And what do you think the student was responding to here? Why were they saying 4/5? Right, there's 5 pieces. So maybe they were thinking about it as a set model. I think they weren't looking at the area. And what often happens is that a wrong answer is often the right answer to a different question. So in this case, we had a little segue and we talked about the difference between a fraction of an area and fraction of a set of tiles. And those are the really exciting times because you can see they didn't just get the answer wrong. They were doing some really interesting mathematical thinking, and it led them to their answer, which is the correct answer to a different question. All right, the next intentional action is to actively discourage dependency on the teacher. And you know, how many times have we given the instructions, we've talked about a problem, we've sent them off, and we immediately get hands up. I don't know what to do. What do I do? What do I need to use? What does that dependency look like in your class? What does it sound like when students are relying on you? Shrugs, yep. Carolyn, is this right? Absolutely. So they do something and go, am I right? They want to know. Or I don't understand. That they don't even want to delve into the problem, Maria, right? They just look at it and go, I don't get it. Often that happens if it's a concept that frightens them, things like fractions or decimals or variables. They can think, oh no, I don't know what to do. And they're just going to click back up. Amy, the power of number talks and number strings to get at different strategies that We all see things differently. I don't think we can underestimate the power of that pedagogical practice. Okay, so what has worked? Okay, Anika, thank you. So what has worked to encourage more independence? That they can expect a question from me if they ask a question. They're not just going to get that answer. So putting it back, going back to some of those prompts that we looked like at on the document. Well, what do you think? What do you know? And directing them back. Directing them back to their peers. You know what? If you're really stuck, take some think time, but then walk around the room. If everyone seems to be struggling, let's stop for a minute. Let's come back together as a whole group and do a mini consolidation. Right? One of the ways that really helps discourage dependency is to help make the problem visible and making math visual. I think so often kids get stuck because they see a bunch of words and numbers and they're not able to decode it. And so making the math visual for them really helps. I just want you to look at this number line here. And for those of you who are in the younger grades, don't be turned off by the X and the Y. Think about what this picture is representing. I love this picture when I see it. It actually came from a conversation on Twitter with some work that we were listening to Kathy Fosno on hashtag #TheMathPod. And yes, so Tiffany, that color coding is another way to make things visible. Using double number lines. I like how they went on top and the bottom here, but using those two different colors, helping them see the patterns. Sorry, I'm just have a little bit of cough there. Okay, I'm going to skip ahead a little bit. Okay, again, the idea of letting them wrestle with important ideas and giving them tasks that they really have to think deeply about. So, for example, open questions are powerful, powerful tools to get kids thinking. So pick one of those graphs. How do you think your students would respond? What support would they need? So it's an open question, so there's a low floor, high ceiling. There's lots of strategies. It's visual. How does this let them struggle with important mathematical ideas? Or which one of them do you prefer? One of the things I love about both of these images is that they are, there's no labels. There's no title. It's letting kids think about what these data, these graphs could be representing. Tiffany and Amy, you both like the second one. Yeah, that whole idea about which one doesn't belong. And it's not just which one is least like the others, but you could turn it into a which one doesn't belong, where they have to make a case for any of the four. And what a rich discussion you could have about interpreting that data and which one gives information visually to them. Okay. The other, the big message we want to give is that when we struggle, it means we're learning. And we've talked a lot about this tonight, so I won't belabor the point. But like we said, kids want to just get the answer. They feel that all math questions can be answered in 20 minutes. But we want them to know that when we're struggling, when we have that confusion, when we have that discomfort, that is something we go through, and it's not going to be permanent. Right? You will go through this, and you will have greater learning. And so one of the things that I think is really powerful is to record somehow some of those struggles when you know, kids are getting frustrated, they're wanting to give up, you take a break, you come back to things, and then in 2 weeks or a week, when there's been this growth and learning, come back to that student work, whether you took pictures of it, whether you saved the chart paper, whether you took pictures of their whiteboards, and say, hey, look at this. 5, 6 days ago, we didn't know how to solve this problem. Look what we've learned. Sometimes I think we have to bring that up to the surface. Beyond a grade or a mark, it's bringing to the surface what they've learned that they didn't know before. And that isn't always obvious in math. I think when we're reading, kids know when they're getting better at reading because they're reading more challenging texts, they're becoming more fluent, they're not stumbling over words. When they're doing a sport or an activity, they know when they're improving because they have ways to measure it. Sometimes in math, we're not giving them ways to measure their growth other than a mark on an assessment or a level or a grade on a report card. And so one of the ways I like to convey that message is to go back and say, you know, this was a problem we really struggled with. We put it aside. Now we've done some learning. Let's go back to that problem. Is it easier now? Do you have more strategies to try it? What do you know now that you didn't know then? So the last problem I want to try together, and I do want to take this time. So it's your last math task for the night. Play with this a little bit. You have a 3 and a 5-liter water container with no markings, except that you know when it's filled, that's their total volume. You have lots of water running. We turn it off in between because we're not wasting water. But you have to use just those containers and the tap. How could you measure out exactly 4 liters of water? So I want you to think about it. Get a picture in your head. Visualize it. What could you do? So I'm going to give you a minute. Hopefully those of you who are still here, who haven't stepped away, I really want to encourage you to try this one. Just like we want our kids to try it, that's my challenge to you tonight. So let's take a minute. Nally, if you could put a timer on. And my push to you is to work on this problem and type your solution in the chat box. But I'm going to ask you not to type until the minute is up. Okay? Off you go.
How many minutes, Kit?
Just 1 minute. All right. So where are our solutions? What did you do? Carolyn, sorry. Come on, you can do it. I know that wasn't the prompt. Carolyn, what would you start with? Amy, you noticed that there was a difference of 2, and you used that information to help you? How did that noticing help you? All right, let's think. Let's talk this out, Shannon. You're going to fill the 3-liter jug, pour it into the 5, and then fill it again and pour it into the 5 so there would be 1 less. Okay, so that's your beginning strategy, but you're not sure how that worked. Okay. Amy, so you think there's something about that difference? Then you're wondering about that. That's a great start. So Anik, if you fill the 5, you're pouring it into the 3. Okay, I'm going to thank you all for giving that question. Do you have another? No, there is no 4-liter container. You can dump water out. My environmental spidey sense says we should be dumping it someplace where we can use it again and not on the ground, but we'll imagine that. All right, so let's look at the combined knowledge here. We have fill up the 5-liter, pour it into the 3. That leaves 2 liters in the 5-liter jug. And Amy, that's where your difference was coming in. All right, so then we dump the 3 out. And yeah, Isn't that cool? We can try problems and come back to them and think it's a brand new question. We don't remember how we did it. So the important part of this one isn't the solution. It's making the plan and trying different things. So I'm going to leave this with you. I would love for you to play with it. Take it to your kids. Think about what visual models you could use. So my request, and I don't want to put any pressure on, but my request is that you take this, think about it, draw a picture, solve it out, and then take a picture of it and either tweet it to me or send it to me in my email that you'll have at the end. And if you get your students to do it, I'd love to see their work too. So we'll move on from there. So we're getting them actively involved in discovering mathematics. Carolyn, we don't have an extra container. We only have the 2. But you can dump water out either on the ground or back in a big tub somewhere that is being used for something else. Sorry. You're going to email me when you figure this out. I know you will. Okay. The last one is we've talked about before about providing opportunities. I've linked here matthews.ca that I'm sure lots of you are familiar with. I'm looking at our time, so we're not going to spend a lot of time here. And I just want to leave you with this thought. How do your students see themselves as mathematicians? Do they see themselves as capable? How can the 8 strategies that we talked about tonight help them develop their mathematical identity, to see themselves as mathematicians? And how do you see them? And I really encourage you to pay attention to the language you use when you're describing your students. Because so much of the language we use in education is about leveling and labeling kids. So you have your level 2s. Oh, those are my low kids. Oh, he's my smart one. All of those things that we don't do intentionally, but they've become part of the language we use to talk about our students. And one of the other challenges I want to leave with you is to become more aware of the words we're using to talk about math and to talk about how our students learn math. And my final question is, this is qualitative. We don't have a measuring tool for knowing whether our students have increased in their ability to persevere. So that's something also I want you to think about is how will you know whether they've gotten better? What could you track? What could you pay attention to identify whether your students are improving? And you know, I know it's May 7th and our thoughts start to think about the end of the year, but most of us still have 6-7 weeks of school left. This is the great time to really dig into and focus on the learning goal of becoming mathematicians who like challenges, who stick with challenges, who aren't afraid to make mistakes, and who are able to live with a little bit of discomfort in their lives. So, I'm going to leave you with that. I'm going to leave you with the water jug task. I really want to hear from you. Carolyn, I might have to track you down because I know that you can draw a picture, you can make a plan and think about how you're going to do this. So I look forward to hearing from you. I look forward to, in a few weeks, send me some feedback. See if you've tried some of these tasks with kids, some of these strategies with kids, and are you seeing a difference? What have you noticed about your students' willingness to take on challenging math? So thank you very much. Thanks for sticking with me on this wonderful evening. And thanks, Mally.
Thanks, Kit. And I want to know the answer to the water shut problem as well. So thanks for sharing
Mally,
that.
you have to figure it out, Mally. You can do it.
I can do it. I can. I have Sunita
right
here. So